Hi, I'm Rod from EV Power, and this is our top secret battery project that we're working on. But the reason that I'm talking today is a safety issue that we discovered. Jamie came in this morning, and as you do, this is a 400 volt pack, and it's split into two levels. So at the moment it's split into two kind of basically 180 volt levels. Now Jamie came in this morning and did a safety test on the pack, so we're testing from terminal to the chassis, and he found that there's a voltage. I just have to look for my multimeter. So as part of our safety testing procedure, which we have here, there should be no voltage, but there is. There's a voltage from the terminal to the chassis. And on a traction battery pack, there should only ever be a capacitive voltage. So what I mean by capacitive is if we go to the top level here, the two levels are isolated from each other. So if we go to the top level here, and I go from a terminal here, and if you watch the voltage here, and I go to the chassis, just keep it on the voltage there, thanks. You can see that there's a voltage, but it drops very quickly. That's the capacitance effect. And I can go to either end of the pack and measure that, and it will drop very quickly. That's a capacitive. But this one at the bottom is not capacitive, and very wisely spotted by Jamie, that is actually not moving. So there is some connection somewhere on the pack, on this battery pack, this bottom battery pack, to the chassis. So we checked all around, checked that we didn't put any screws through wires or anything.
I was concerned that I might have put a screw down through one of these cables.
Yeah,
but that didn't happen.
Cables. That didn't happen. So eventually we traced it back to this terminal post here. Has 0 volts on it to the chassis, which is a bit of a giveaway, because if I take that off there and
is that pack negative there?
Got me. Matter. Yeah, it could be pack negative. Yeah, it's not pack negative, but it's negative for that. So now, if I check from this was previously connected to that terminal post.
So you're on the...
So now we can see the capacitive effect has come back in. It drops very quickly. And if we go back to the other end of the pack, I'm probably blinding you with science here, but I'm just kind of excited about this because it's quite a revelation. That is now capacitive. So we've got a capacitive joining, from some of the terminals to the chassis, which you would expect because it's a large thing and you've got large surface area, for capacitance to happen. So what that means is that somehow this terminal post here must be conducting to the chassis. So I thought at first Jamie had done a botched job of
and
making
I made this with, it's just HDPE plastic with a bolt through it, resin poured in the bottom of the bolt. There's clearly no contact between metal to metal.
So what that leads us to is if we, instead of putting that on volts, we put that on ohms. So we measure the resistance from the terminal post, which is not connected to anything, to the chassis. It's 1.39 k ohms. Now, how can that be? So we did a bit of forensic checking here.
And first we checked this piece of plastic, which is an offcut from the fuse holders I made, which are here, made in the same way.
So what we did was we checked this piece of plastic here, which is a different offcut, same colour, everything looks the same, HDPE plastic, and there seems to be no connection. Like however close I move those probes together, it's infinite ohms, infinite resistance. This piece of plastic, we can measure a resistance across it.
And this is the offcut that I made that from.
Yeah, which is quite a revelation. You can see that there's some kind of resistance happening across it. So it's not a perfect insulator.
Not safe to use.
not safe to use at all. If you're making a battery pack, check what you're making your insulating pieces, components out of, because some plastics conduct electricity.
A big lesson from today.